Hey guys, so how's everyone doing? So today we're going to perform a classification algorithm using the decision trees algorithm on the iris dataset. So we have already used the iris dataset in a previous video by performing k-means clustering, but that we have performed unsupervised learning. So we didn't give him any training data. But here we're going to give a training data and give a test data, and since we already have the results, we're going to find the results. All right. So yeah, let's just get into it. And the steps involved, you can just have a quick look at it, but I'm going to be going every step either way. And so we only require three libraries for this, that is NumPy, Pandas, and Matplotlib. And so here we go. First, importing the dataset. I have imported the iris dataset. You can find it in the UCI machine learning repository. And now data.head. So yeah, so all these are iris setosa. And if you've seen the clustering video, we have tried to find the area of each of these, but we're not going to do that here. We're just going to directly put in the parameters. Okay. And so I'm just finding the type of species that are there. So there's only three species, that is Iris setosa, Iris versicolor, and Iris virginica. So our aim is to build a classification model. Suppose we give them new parameters, we are supposed to classify whether which type of flower it is. Okay. So just to make the model understand this easier, I'm converting this to 0, 1, and 2 respectively. So Iris setosa is 0, Iris versicolor is 1, and Iris virginica is 2. So going on, as you can see, all this Iris setosa has become 0. Yeah, so this dataset species contains 0, 1, and 2. And I've dropped ID because it's not really contributing to our model. Okay, now I'm separating the dependent and the independent variables. So the independent variables are the sepal length, sepal width, petal length, and petal width. And the dependent variables the species. So we're just grouping all this into a variable X. And yeah, so that's why it's all the columns till the last one. And Y is only the last one. So as you can see, this array is created for all the columns here. And this array is created with only 0, 1, and 2. All right. Now scaling the model and standardization. So what is scaling? So basically, so as you can see, these numbers, they have a huge range within them. Okay. And so why do we need to scale the model? So we're trying to bring everything towards a closer towards the mean. So that is easier for the model to understand. So how we do this is there are two methods. So one, in this method, I'm going to follow standardization, that I subtract each element from the mean and divide it by the standard deviation. And the other method is just subtracting it from the minimum and dividing it by the range. That is called normalization. So today I'll be using standardization. So we imported from sklearn.preprocessing, and this function is called standard scaler. And now, as you can see, so we're getting a lot of values. So a lot of small values. So this is done from subtracting each element from the mean and divided by standard deviation. So everything is done in the standard scalar function. All right. So that's why we standardize the values. And now I think we're ready to put everything in the model. So now we're just splitting the train set and the test set. So the test size is going to be 0.2, so that 20% of the data is going to be in the test set. And from sklearn.tree, so you can go to Skycelearn website and find out how to import the decision tree classifier. And so that's why I'm putting the X train and the Y train in here. So this is how I'm going to train the model. And you can just go through all this. It's not that important. And yeah, so I'm trying to get a model accuracy, and the model is 100% accurate. Okay, so the model didn't make a mistake here while checking with the test set. Okay, so now let's just check ypred with the test set. So we're checking actual versus predicted. So the predicted values are coming from the test set, and the y test contains the results there. And as you can see, there's no difference here. So the actual predicted value is 2, the actual value is 2, the predicted value is 2. And you can see there's no difference here in the test set. So our model is perfect. Okay, but just a side note, so in this simple data set, it's fine, but usually when a model is perfect, that means there is something wrong with it. Okay, so now I'm just plotting a confusion matrix just to check whether my model is 100%. And yeah, this confusion matrix just confirms that my model is 100% perfect. So there are 11. So this I think is Iris setosa, this is Iris virginica, and this is Iris versicolor. And yeah, so there are no mistakes in the case. So it didn't see an Iris setosa flower and say, oh, this is Iris versicolor. It says Iris setosa is Iris setosa. So there are no mistakes at all. And you can see there are a total of 29 here, and 11 plus 13 plus 6 will also equal to 29. All right. So, no, oh, sorry, the 30 here. So 11 plus 12 plus 6 is also 30. All right. So moving to visualizing the classifier. So we're just going to visualize the decision tree. So decision tree works like an if-else loop. So suppose we go straight. We see a car running towards us, and we see a horse running towards us, and we have to make a choice on where to go. So that's what a decision tree does. I mean, not a very life and death situation, but that's what decision tree does. So we're just going to visualize this, and yeah, this is what we have here. So now we're not going to understand these values per se because we have scaled them. these are all the scale values. So first it takes this value, and if this is valid, it moves here, and depending on this, it goes here, and finally it classifies it into this, or this. Okay, so that's how a distance tree classifier works, and you can just have a look at how it works over here. Okay, and summary distance tree classifier is 100% accurate. So I just show you the visualization once again, so you can clearly understand what the distance tree algorithm really is. So that's it for this video. Thank you all for watching. Hope to see you all again.